Imagine a mesmerizing cosmic symphony, orchestrated by an boundless array of celestial bodies, suns, worlds, and moons, all resonating in flawless harmony. Yet, within the stellar ensemble, a specific segment has captivated stargazers for millennia. Exoplanets. These enigmatic realms lie beyond our own solar system, cloaked deep within the immense Milky Way galaxy. What might astound you is that among these countless heavenly entities there exists an exoplanet so strikingly akin to Earth, so remarkably familiar that it could very well be our planetary twin. Let us set forth on a voyage into the intriguing domain of Proxima B, a world positioned a mere 4.2 light-year from our home planet. The James Webb Space Telescope (JWST) is revolutionizing our approach to the pursuit of comprehending these mysterious orbs. Envision for a moment your thoughts drifting through the colossal astronomical expanse of the Milky Way, a galaxy sheltering over a quadrillion exoplanets. To visualize this, imagine each exoplanet being the size of a single grain of sand. Not only would this completely fill the Grand Canyon, but it would also be enough to construct a new geological marvel on Earth, the Grand Canyon 2.0, stretching an astonishing 4 million km in length. What's even more astonishing is that approximately 20% of these far-off worlds have been identified as Earth-like in terms of their geological composition and atmospheric properties. This suggests that for every 5 exoplanets one could bear a striking resemblance to our own world. But the narrative doesn't conclude here. Accompanying these planets could be another quadrillion satellites, rocky companions analogous to Earth's own natural satellite, engaged in gravitational ballets with their parent celestial bodies, as reported by Space.com. If you are anticipating the revelation of another cosmic object capable of sustaining life, or perhaps one that might then the universe presents infinite possibilities. Now that we've begun to unveil the immense scope of the cosmos, it's time to present the master craftsman capable of depicting its intricate subtleties. The James Webb Space Telescope, this cosmic scrutinizer, with its telescopic lens replacing the typical magnifying instrument, far surpasses even the most sophisticated optical apparatus. Its 6.5 m primary mirror, 2.7 times grander than Hubble's, empowers it to discern even the most tenuous stellar glimmer, billions of light distant, analyzing the planets that encircle them. However, the James Webb is groundbreaking not solely for its unparalleled observational prowess, but also for its cutting-edge technology, which incorporates infrared sensors and spectrographs. These instruments can do more than simply observe. They can meticulously examine the distinctive light signatures emitted or reflected by celestial entities to decipher their atmospheric conditions, constituent elements, density, and even mass. Functioning as celestial forensic specialists, they can determine if a planet contains water, organic compounds, or even oxygen. The James Webb Space Telescope is not merely an enhanced iteration of Hubble, it represents a monumental leap forward. If Hubble's revelations left you amazed, prepare for an even more magnificent series of disclosures as we persist in exploring the complex topography of the cosmos. One star in particular beckons our scrutiny, Proxima B. Since its revelation in 2016, this enigmatic world has emerged as the central character of a cosmic saga, replete with complexities and paradoxes that have captivated astronomers and researchers alike. What renders Proxima B noteworthy? For starters, it is situated in our cosmic vicinity, merely 4.2 light-years away. To put this in perspective, if you could traverse at the velocity of light, you would arrive at Proxima B in just over 4 years, the identical duration it takes for a presidential tenure to conclude, or for your preferred television series to become outdated. But the proximity of this planet holds significance for more than just practical considerations. It resides within a universe that spans 93 billion light-years, so discovering a world so near yet so replete with promise for scientific inquiry is akin to unearthing a rare gem in a mountain-sized heap of stones. This precious find could harbor vital secrets about existence and our position within the grand design of the universe. Proxima B allure is not solely founded on its closeness to Earth. Astronomers surmise that it may not only resemble Earth but could even be Earth's doppelganger, Earth 2.00, positioned within the so-called habitable zone of its parent star, where conditions are precisely right, neither excessively scorching nor overly frigid. It may offer the potential for liquid water. Envision waterfalls plummeting down precipices, vast rivers meandering through alien landscapes, and oceans as mysterious and profound as Earth's Mariana Trench. Nevertheless, before we allow our imaginations to run wild with notions of vacationing on Proxima B, we must contemplate some of its peculiarities. For instance, one day on Proxima B spans an astonishing 11 Earth days. Imagine sunrises that gradually unfold, heralding a new day, followed by prolonged sunsets extending into golden hours that photographers covet. While this might sound like an idyllic scenario, it poses intriguing inquiries about the planet's climate and habitability. Would our human biological rhythms adapt to this unfamiliar cycle of illumination and darkness? Would we require more nourishment on Proxima B? Could we slumber in the same manner as we do here on Earth? Life as we perceive it would be both curiously familiar and perplexingly alien. Nature seems to present us with a conundrum encased in a riddle. Could Proxima B's civilization be analogous to ours? A query that challenges our presumptions about what renders a planet suitable for life. The JWST's analytical masterpiece. But how can we procure precise, reliable data about a world we've never visited? The James Webb Space Telescope deploys all of its capacities to address this query, functioning as a versatile research facility in orbit. Thanks to its pioneering innovation, astronomers can not only observe distant planets but also scrutinize them with advanced instrumentation through infrared sensors and spectrographs. The telescope can analyze the electromagnetic radiation emitted and reflected by these far-off celestial bodies by dissecting the exact wavelengths of light absorbed or released by various substances in a planet's atmosphere. Scientists are capable of conducting a remote diagnosis analogous to a biopsy on these extraterrestrial domains. This empowers them to evaluate atmospheric pressure, density, and the potential existence of life-sustaining constituents like H2O, carbon-based molecules, and even oxygen. The James Webb Space Telescope is not merely another observational apparatus. It is an analytical masterpiece. It enables humanity to transition from speculation to verifiable knowledge, expanding our cosmic comprehension and altering our perception of what may exist beyond our terrestrial confines. Just when we presumed we had deciphered all the cosmic enigmas, a startling development emerged. Researchers, utilizing the James Webb instrument, detected something extraordinary from Proxima B, a transmission so atypical and intricate that it resonated across academic institutions and digital platforms, igniting debates on the likelihood of intelligent extraterrestrial existence. This electromagnetic emanation was unlike any other previously documented, so meticulous and rhythmic that it suggested the possibility of an advanced